Let us look at rectification of a curve. Rectification is a process of finding the length of a plane curve y is equal to f of x. So we have a curve on a plane and we know that the rate of change of the arc length with respect to change in x is equal to square root of 1 plus dy by dx square. So here S is the arc length of the curve measured from a fixed point on the curve, say from x1, y1 to x2, y2. Then the arc length is equal to integral of ds by dx from x1 to x2, which is equal to the integral from x1 to x2 of square root of 1 plus dy by dx square dx. Or if you want to look at it with respect to y, we have s is equal to integral from y1 to y2 of ds by dy is equal to the integral from y1 to y2 of square root of 1 plus dx by dy the whole square dy. Now, let's look at it with an example. So let's say we are given x to the power of 2 by 3 plus y to the power of 2 by 3 is equal to a to the power of 2 by 3. If we plot it, this is what we get. And we notice that the curve is symmetric across both x-axis and y-axis. Now, even without plotting the graph, we can figure out that it is symmetric across x-axis and y-axis. So since it is symmetric, that means we just have to figure out the arc length of, say, first quadrant part of the curve. And then we just multiply it by 4 to get the total arc length. So we can focus on the first quadrant curve of length s, then the total length would be 4s. Now to do this, we first differentiate the given curve. We get, differentiating this, 2 by 3 times x to the power of 2 by 3 minus 1 plus 2 by 3 times y to the power of 2 by 3 minus 1 times dy by dx is equal to, this is a constant, so 0. Now simplifying that, we get 2 by 3 times x to the power of minus 1 by 3 plus 2 by 3 times y to the power of minus 1 by 3 times dy by dx equal to 0. And solving for dy by dx, we get minus y by x to the power of 1 by 3. Okay, so we have the dy by dx. Now we integrate. So s is equal to integral of square root of 1 plus y by x to the power of 2 by 3. Why 2 by 3? Because dy by dx is 1 by 3. But remember, it is square. So y by x to the power of 2 by 3 dx. But of course, this is not supposed to be a indefinite integral. So we need to identify the limits as well. So here, what is the limits? Limits is 0 to a. Since we are talking only of the first quadrant part of the curve, it starts from 0, x equal to 0, to x equal to a. So from here to here is what we are talking of, 0 to a. And taking the LCM, we combine these two terms. We get x to the power of 2 by 3 plus y to the power of 2 by 3 divided by x to the power of 2 by 3 dx. Let's manipulate this. S is equal to integral from 0 to a of square root of, the numerator is equal to a to the power of 2 by 3. So square root of a to the power of 2 by 3 by x to the power of 2 by 3 dx, which is equal to integral from 0 to a of the square root and the 2 of the 2 by 3 in both numerator and denominator cancel out. So we are left with a by x to the power of 1 by 3 dx. This can be written as s is equal to integral from 0 to a of a to the power of 1 by 3 times x to the power of minus 1 by 3 dx. a to the power of 1 by 3 is a constant, so we take it out of the integral. And we have a to the power of 1 by 3 integral from 0 to a of x to the power of minus 1 by 3 dx. Now we integrate. So a to the power of 1 by 3 times x to the power of minus 1 by 3 plus 1 by minus 1 by 3 plus 1, which gives us a to the power of 1 by 3 times x to the power of 2 by 3 by 2 by 3 from 0 to a, which is equal to a to the power of 1 by 3. Denominator 2 by 3 becomes 3 by 2 when taken to the numerator, times, taking care of the limits, we have a to the power of 2 by 3 minus 0 to the power of 2 by 3, which is 0. So we have s is equal to 3 by 2 times a. But this is the arc length of the first quadrant. We multiply it by 4 to get the perimeter of the asteroid. 4 times 3 by 2a, which is equal to 6 times a. So whatever is a, you just have to take 6 times of that. Figure out the perimeter. So that was one example. Now let's look at another example. Okay, in the second example, let's take a circle. We know the formula of that is x square plus y square equal to r square, where r is the radius of the circle. Now we want to figure out the arc length of the entire circle, that is the entire circle's circumference. So let's do that. If we solve for y, we get y is equal to plus or minus square root of r square minus x square. So what we'll do is we'll take only the upper half, that is a semicircle on top, and figure out the length of that arc. Then we double it to get the circumference. So y of x is equal to square root of r square minus x square for x in minus r to r. Now we differentiate this. We get dy by dx is equal to the derivative of r square minus x square to the power of 1 by 2, which is equal to 1 by 2 comes down times r square minus x square to the power of half minus 1, which gives us minus half, times minus 2x. Simplifying this, we get minus x by square root of r square minus x square. Now, let's take ds by dx. So ds by dx is equal to square root of 1 plus dy by dx square. Dy by dx is minus x by square root of r square minus x square. The square. Now this is equal to minus disappears because of the square. Numerator becomes x square. From the denominator, square root disappears. So we have square root of 1 plus x square by r square minus x square. Combining these two terms, we get square root of r square by r square minus x square. So the length of the arc, the upper part, is equal to the integral from minus r to r of square root of r square divided by r square minus x square dx, which is equal to, now r is a constant, take it out of the square root, becomes r. Since it's a constant, we take it out of the integral as well. So r times the integral from minus r to r of dx by square root of r square minus x square. Now, this integral is equal to pi. Oh, how did that suddenly appear? Let's solve this integral, definite integral. Let x equal to r sine theta. Differentiating, we get dx is equal to r cos theta d theta. Square root of r square minus x square is equal to r cos theta. Just move it around. What do you get? R square minus x square is y square. So y is equal to square root of r square minus x square. And y is equal to r cos theta. Now, we have to take care of the limits now because we are using substitution. So x is equal to minus r means minus r is equal to r sine theta. So for what value of theta will sine be minus 1? Theta would be equal to minus pi by 2. Similarly, x equal to r means r is equal to r sine theta, which implies sine theta equal to 1, which means theta is equal to pi by 2. So now our integral becomes integral from minus pi by 2 to pi by 2 of r cos theta d theta divided by r cos theta. R cos theta gets cancelled in both numerator and denominator. So we are left with integral of minus pi by 2 to pi by 2 of d theta, which we know is equal to theta from minus pi by 2 to pi by 2, which is equal to pi by 2 minus pi by 2, which is equal to pi, which is what we had mentioned here, that it is equal to pi. And since it is equal to pi, the circumference is equal to 2 times the length of the upper semicircle. That means for the full circle, it is equal to 2 times L upper, which is equal to 2 times pi r, because here we have r times this integral. This integral is pi. So 2 pi r is the circumference of the circle. Again, here it depends on the radius. So if we change the radius, accordingly the circumference would also change. So remember, dy by dx gives the slope of the tangent at a point. ds by dx gives us the rate at which arc length s changes with respect to the change in x, and it is always positive. And the integral of ds by dx from a to b gives us the accumulated arc length. That is rectification of a curve. If you found this session helpful, don't forget to like, share, and subscribe. Questions, suggestions, and opinions are always welcome. Thanks for watching. See you in the next session. That's it for now.